today we're going to talk about service mesh patterns. So thank you very much for coming. Thank you very much for being here, and to be aware that you're going to learn really cool things about service meshes. I'm just Alex Soto, I work in Red Hat. I'm the author of several books, magazines. I contribute with several places. And let's say that everything started like maybe 6 to 7 years ago, when our application was something like this. It was like a monolith where it was everything there. But of course, inside you can see here in this picture that our monolith contains some modules, and each of these modules contains some components. So at the very end, our monolith was composed by modules and then components, which was great. But then let's say that maybe like this, maybe 5 years ago, 4 years ago, depending on the company, we decided that it could be a good idea to just break down all these modules, all these components, breaking down and split it across a network, which is, creating the microservices. So at the end, all these microservices was just services, all of them interconnected using network. And of course, each of these microservices might contain some database, and each of these services contain its own database. And of course, there is a multiple points of entry in a microservice architecture, and for this reason, it's really important to have an API gateway to just control which services exposes what. But at the very end, if we are thinking about microservices architecture, it's just distributed computing, the same that we did in the past. If you are coming from RMI or Corva, it's exactly the same. Just one service that calls another service, and this other service calls another service. It gets a response and then sends back the response. So in terms of, let's say, networking, it's more or less the same. The problem is that we as developers, we think that, okay, developing a monolith and developing a microservices, maybe it's not a big difference, in the sense that in the past, in my monolith, I was calling a function, and this function was a memory call. And nowadays, I'm just doing a microservice or a network call, right? One microservice calls another microservice, and it's just a network call. I can just do a request to this endpoint, and then I get it to response. So in terms of, for me as a developer, I don't care if it's a memory call or it's a network call, because it's more or less the same. The problem is that this is not true. And now we get all these policies of distributed computing. We need to avoid thinking in all this stuff, in that it's true, because it's not, it's false, okay? We cannot think that the network is relevant, because it's not. As developers, we think that, network will always be up and ready, but the truth is that's not. We cannot think that the latency is 0, because it's not. We think that I'm going to send a request, and in 0 time, I'm going to get the response, and that's not in that way. Also, we think that the bandwidth is infinite, right? We can send gigabytes of content files through the network, and that's fine. We also tend to think that the network is secure. I mean, at the end, it's inside our own backbone, so nobody can access to this network. But the truth is that a lot of attacks happening within our backbone. We also tend to think that the topology does not change, that there is only one administrator, the transport cost is 0, and the network is homogeneous. So you can see that usually as developers, we might think that this is how the network works, but the truth is it's not working that way. And think about this. What's happened if I'm with my network mesh, in my microservices mesh, with all these services deployed, and then there is one service that it's failing? Now, what's happening is that there is a cascading of failures. Just the services that depends on that service, plus all the transitive services, they are going to fail as well. So instead of having one fail in one place, what we are having is several failures across all these services. And notice that this is something really curious, because when we are talking about microservices, we think, or we tend to think, that it's about isolation, right? That every microservice is isolated. And that's true until one of these services fails. Because then, when there is a failure in one service, there is a bunch of failures across all the services. So this is what is called temporal coupling, right? Which basically says that everything is isolated until something fails, and then everything is coupled. So as you can see, done properly, networking is an art, done properly. So we need to take care a lot of all these network connections. And for the reasons, when we are talking about microservices, there is this kind of, like to say, cross-cutting concerns for microservices or microservicilities, right? These are some concerns around a microservice. We have the service itself with the business logic, but then there is a lot of new content. For example, we need to define an API, we need to define a way to discover other services, how to invoke other services, the concept of elasticity to scale up, scale down, the concept of resilience, what's happened if there is one service that goes down, defining a pipeline to deploy your services, the authentication problems, how we authenticate between services, how we log, how we monitor, how we trace all the things that are happening inside our mesh. So as you can see, because of microservices, now we need to take care of all these concepts as well. So you can think that this is really a problem, because now we need to take care of a lot of more things. But also you can think that it's an opportunity to start doing things in the right way. And probably if you're using Kubernetes or OpenShift, which at the end, OpenShift is the Kubernetes for enterprises. If you're using Kubernetes, then some of these concepts are already covered. For example, the part of discovery and invocation is covered by Kubernetes, and you can see that there is also elasticity with the concept of scale up, scale down. You can really easily scale up any service to 100 instances and then scale down to 1 instance. Or even if you start using, for example, Kinetic, you can scale to 0. If you are using, for example, OpenShift, which is also Kubernetes, you're getting everything from Kubernetes plus the pipeline, the logging, and the monitoring. But we're still having some remaining parts here. You can see, for example, the resilience, the authentication, the tracing, and the API is something that we are not covering with Kubernetes. So what we end up is just embedding these capabilities inside each of the service. So for example, we've got our service A, and then we need to embed the discovery, the load balancer, the resiliency, the metrics, the tracing, all this stuff are put it inside the service. So we've putting our business logic plus all this stuff. And the same for service B and the same for service C. And this has two major problems. The first one is that you are going to start copy pasting, because nobody is doing copy pasting nowadays, right? And you are doing all this copy pasting from service A to service B and so on. This is one of the first problem, and you know that copy pastes are not so good. The second thing is that what's happened if your service A is in Java, the service B is in Go, and the service C is in JavaScript. Then you need to learn how to do resiliency, metrics, and tracing for Java. Then you need to do the same for JavaScript and the same for Go. So you need to learn 3 different frameworks. But let's think about this. What happened if I told you, if all these cross-cutting concerns, all these capabilities are here because of microservices, and they are here because of the network, because we added all this network stuff, why we are not moving all these things into a network level, not at application level? Application level should continue to contain only business logic and move all this stuff into network level, into infrastructure level. This is where they belong. And this is exactly what service meshes is doing is just taking all this stuff and putting it on an infrastructure layer. So as you can see now, we've got just service A and service B and service C. And this works because a service mesh intercepts all the network traffic that are happening from service to service, and then they manipulate. And they can manipulate in several ways. For example, for logging, or for example, for rerouting. So they can reroute a message from A to another service instead of B. Or they can encrypt the service. So there's a lot of functionalities that can be implemented with the service mesh. And this is what we're going to see today. Please see that in this presentation, I'm just showing you some advanced topics of service meshes. So you're not going to see deeply an A/B testing or a canary deployment. You're going to see really interesting things. The first one is about traffic routing. The first thing that we can do is blue-green deployment. It's the most trivial thing that you can do with a service mesh, which is just instead of sending all the traffic to service V1, you just say, okay, now I want to send all the traffic to service V2. Easy. You just need to update the mesh definition. The second one is you can do a canary release. You can start sending 90% of the traffic to service V1, and then 10% of the traffic to the same service, but the version V2. Right? This is what it's usually this is used for testing in production. Another thing, since you are manipulating all the traffic, you can still do any kind of routing with the traffic. You can decide that instead of routing the traffic by percentage, you can do it by some kind of specific attributes that you define. For example, you can say, I want to send all the traffic to service V1, but if the range of IPs of the requests are inside this range, then send it to the version V2. Or you could choose another, which could be instead of the IP, it could be the browser. If it's a Firefox, I send it to this version. If it's a Chrome, it goes to this other version. Or you can even set, if it comes from a laptop, it goes to this version. If it comes from a phone, then it goes to this other version, and so on. So you can start doing all this kind of dark canaries stuff thanks of a service mesh. You can do, for example, shadowing traffic. Shadowing traffic is a technique that is used to do testing in production, which basically means that you are sending the same request to two services. You're sending the traffic to service V1 and also to the service V2. But notice that now the lines are different. One is dashed and the other not. This is because the service V1 is receiving the request and sending the response. And this response is the one who is going to send back to our colors. But the second one, the dashed one, the one that goes to version 2, it's a fire and forget request. It sends the request, but we do not care about the response. It's simply ignored. And notice that it's really useful when you want to release a new version to check if there is any kind of regression. Other things that we can do is future graduation. In this case, a future graduation is something that we use in Red Hat, which allows us to deploy several versions of the same service and let the user decide which service they want to use. For example, they have a combo box when they can choose if they want to use the production-ready features or the beta-ready features or the experimental features. So depending on this configuration, we are rerouting the traffic to any of these pods or any of these services. What's happened when the experimental is mature enough to promote to beta? Well, it happens this. There is just a promotion where now V2 is production, V3 is beta, and there is no experimental version yet. And another thing that you can even do is use service meshes to work as or to implement a multi-tenancy approach. So you've got one pod with one version, which in this case there is no version, is X, is the service X. And then we've got the client green, which stores all his data to DB1, the yellow to DB2, and the red to DB3. So depending on the request, if the request comes from our green customer, then the request is automatically route to DB1. But if the request comes from the yellow one, then it's reroute automatically to DB2. So we can implement this kind of multi-tenancy by rerouting traffic depending on our clients. Of course, service meshes also implement circuit breakage patterns or resiliency patterns. This is something that, if you remember, it's not covered by Kubernetes alone. We need someone at top of Kubernetes to implement all these kind of patterns. And this is a service mesh. Service mesh implements, for example, the retry pattern, which is just, I send a request, and if the response is an error, for example, a 500, then I'm going to automatically retry the same request. And notice that this is happening at infrastructure layer, at the service mesh layer, not an application layer. Then, of course, you can define the number of retries, the delays, and so on. But this is happening, as I said, at bottom layer. You can, for example, also use the bulk ahead pattern. The bulk ahead pattern basically limits the number of concurrent requests that a pod can, or a request that can be sent to a pod. So, for example, you can say, we only want 10 concurrent connection to this pod. And the reason for this is that maybe the business logic behind this pod, it's really it's really slow, and we don't want to saturate that pod. It's using a lot of CPU, for example. Then what we want to do is just try to limit as much as possible the number of concurrent connections to this pod. Another thing, it's a circuit breaker. It's a pattern that probably most of you already know, which basically it's similar to bulk ahead, but instead of limiting the number of requests for requests, which is just saying is like, okay, I'm going to send a request, and if this request fails, then I'm going to remember that this service is failing. Then I'm going to send another request, and then maybe this request probably is going to fail as well. So I'm going to send another request, and probably it's failing. So when I reach some threshold error level, then after that time, I'm going to open the circuit. Opening the circuit means that no further request is going to be sent to the service, right? Then any other request, instead of trying to make the call to that pod, it's just going to send back that it's failing. And why this is useful? The reason is that usually when it's happening in this kind of situations is that because this pod that is getting a lot of requests, it's really busy at that time. So what you want to do is just not sending more requests to this busy pod. So you are just saying, okay, pod, I'm not going to send you any more requests. I'm going to just send an error, and I will let you there wait some time to see if you recover or not. And then after some kind of period of time, I'm going to send you another request to see if you have been recovered or not. Another concept that it's really specific to service meshes, retry, bulkhead, and circuit breaker are something that you can implement on the code, if you will, with any framework out there, like for example Istio in the case of Java. But this one, the pull injection, is something that just works with service meshes and Kubernetes. Basically, it works like this. I've got a pod, and a pod which is the service A, which is sending a request to service B. And probably this service B is scaled to 3, 4, or 5 instances. Then what's happened if I send a request to one of these pods and this pod returns an error? Probably if I send another request, this pod is going to fail. So instead of sending more and more requests to this pod, what I'm going to do is just park this pod. So I'm going to put this pod in quarantine. Well, yeah, I know that today it's a bit, funny word, but it's like this. You are just taking this pod from the pool of pods that that are eligible to serve a request and it's going to put in quarantine and wait some time. Meanwhile, the requests will go through the rest of the pools. After some period of time, this pod is going to get back to this pool of eligible pods, and it will continue receiving requests. Notice that if you are using pool ejection, then you are able to recover some pods that might be able to not process requests because of being very busy. And of course, you can even implement request timeouts. One of the major errors that happens out there is that we as a developers always use the default parameters, right? When we want to do a REST call to another service, we just said, okay, let's do a get, and we don't care about the defaults. And usually these defaults are like 30 seconds, 10 seconds, something like that, right? So it means that when we're going to do a request, we're going to wait 20 seconds until we get the response. If there's even any time a response. If not, we're going to just set a timeout. So it's really interesting to protect the calls across our service mesh with some request timeouts at infrastructure level and not depend on developers level. And a good strategy is doing automatic retries plus pool ejection. You'll see in the demo why. Of course, also in implement security, I would say that talking with a lot of Red Hat clients, most of them, they say that they just want to adopt Istio because of security. The other features are just side effects. For example, you can implement mutual TLS. So you have your service that it's doing requests with HTTP, but the communication between services are done with HTTPS. And this is managed automatically by the service meshes. So they just, take care of revoking certificates, creating a certificate, distributing the certificates across all the mesh. Everything is managed automatically. You just need to do, I want to do a request from A to B, and meshes takes care of doing all the HTTPS stuff. You can create rate limits as well. You can implement authorization for services. Basically, what this means is that in microservices, usually you use GWT or job for authenticating and authorization tasks, and basically it's just a token. Then this token needs to be verified, check that it has not been modified, that has not been expired, and so on. And usually you do this kind of stuff at application level, but with service meshes you can do it at network level. We're going to see this in the demo as well. Also, you can create black and white lists, so you can define who can make requests to whom and who are forbidden to request. Observability, it implements metrics, unified logs, distributed tracing, and also what I like to call the mesh, since all the requests and all the response goes through this service mesh, we've got all the information to define all the metrics of the requests and the responses, all the logs that is happening across all the mesh, or how to correlate all the requests at once. It also helps you to implement some kind of testing in production stuff. Helps you, for example, in doing pod virtualization. What's happening if I have a new pod and I just want to isolate this pod for testing? Then I can just create a virtual pod and just magically send or free route all the traffic instead to the Z pod to a virtual pod. We just have some kind of canned answers. You can go to a DB virtualization. If what's happening if I have B2 and B1 and I want to test B2, but I don't want to write this dummy data inside my production database, then I can just reroute the traffic to a virtual DB, which, for example, Tate is an application from JBoss, which allows you to do that, and you just can send all the reads to the real DB and all the writes to a throwaway DB. You can also inject full injections, or you can work in a multi-environment, so you can send, for example, all if the user is dev123, then I want to send all the traffic to this namespace. But if not, it goes to the production namespace. So I don't want to explain more and more patterns because you've got the slides. Let me show you in live with Istio how this works. Let's see. I've got here my pod. You can see it. Well, let me show you quickly. I've got here K9S. And see that I have customer calls preference, and then I have recommendation V1 and recommendation V2. So if I do a call, by default, now I got nothing installed, just the service mesh. You can see that I'm going from V1 to V2, V1 to V2. So it's just, doing a round robin approach. If I want to, for example, I want to send all the traffic to V2, it's just a matter of defining that there is these services. Okay, that are already there. And I can just say kubectl apply -f istio files virtual service v2, and now we do a curl again. You see that I am always going to v2. If you want to see this file, you'll see that here, that I'm just saying that I want to send all the traffic to v2. Now, yeah, this is the simple example, right? Let me do more interesting stuff. Let me remove this rule. This is one. And now let's try to do more interesting things, which is, for example, resiliency. Let me scale up recommendation V2 to have 2 replicas. So now, as you can see, I've got customer, I have preference, I have recommendation V1, I have recommendation V2, and I have another instance of recommendation V2. So I have 2 instances of the same service. Now, what's happening if I do a call? You see that I'm going V2 again, I'm going V1, I'm going V2, and I'm going the other V2. Now I'm going V1, now I'm going V2, and now another V2, because at the end I've got all these spots. Now, oops, sorry. Now let me go inside one of these spots. For example, this one, I'm going to shell inside this pod. So now I'm inside the pod, and I'm going to do call localhost 8080 misbehave. So basically now what I'm saying is that all the requests that goes to this pod will return a 503. Notice that here I do localhost 8080. You see, sorry, let me put this in this way. You can see that it's return a 503. Notice that here I was just doing calls, and I was getting V1, V2, V2, V1, V2, V2, V1, V2, V2. Now I'm doing call, and I'm getting V2, and now V1, and now V2, and now V1, now V2, and now V1. But there is no error. Why? This is happening because what is happening under the covers is that I'm sending a request to the V2 that is failing. I get the response saying this service is failing, and I program an automatic retry. So then I'm just doing an automatic retry. I'm just sending the same request again, but the pod that it's failing, it's put in quarantine. So it's out to be an eligible pod. Then the request will go to the running pod. Then the response will be correct, and it's send it back to the user. So notice that now, without changing anything in my code, I'm making my code more resilient. I'm not doing anything, just automatic retries, pull ejection, and done. My request, that my client will never notice that his request is failing. Now I can do just here a call localhost 8080 behave. Oops, local. Okay, now again it returns 200, and now if I start doing calls again, you see V1, then V2, and then V2. V1, V2, V2. The reason is that the pod becomes healthy again, so it's not necessarily doing any retry, and the request goes again to all or to both of the recommendation pods. Let me scale down again. Scale to 1. Oops, here. Okay, now again we've got customer preference recommendation B1 and B2. Okay, now let's do another interesting thing. Let's start securing the communication between all services. This is customer and this is Istio proxy. In case of Istio, it's using a sidecar approach, which basically is like I have my customer, which is the business service, and then I'm just creating an Istio proxy, which is an envoy proxy as a sidecar, which is intercepting all the traffic that is happening from customer to other services. And all the traffic that is coming from other services to customer also goes through this Istio proxy. This is how Istio works. Other service meshes uses other approaches. Then let me shell inside this customer pod. Sorry, this the envoy proxy of customer pod. Then this is the IP 10. Okay, now I've got here this script. Okay. Okay, basically now what I'm doing is just sniffing all the traffic that goes through this pod. Now, what's happening if I do a call? Here you can see all the stuff, and you can see that this stuff is not encrypted. It's in plain text. I don't try that you understand all of these things because this is the body message, but you can see all the headers here that it's commenting into preferences. This is your attributes, the user agent, and so on. Okay, now let's say that I want to protect this communication with HTTPS. Okay, one thing is like tell to the developers, okay, you need to change, you need to start using HTTPS client, you need to configure the certificates, you need to be aware that we're going to revoke certificates and we're going to refresh certificates and so on. This is one way of doing it. Or if you're using Istio on service meshes, just apply these settings at infrastructure layer. Let's do a kubectl apply -f. Istio files authentication enable TLS. So basically I'm saying I want to enable TLS across all my mesh. And finally I need to define which services I want to apply in TLS. In this case, I'm just saying all the TLS and just applying this. If you want to see these files, here you see that I'm saying that I want to apply mutual TLS through all the services from this namespace. Okay, now I'm just applying these resources and I'm going to do the curl. Let me see here. Notice that now everything is encrypted. There is no headers. Here, well, let's check. Okay, now here is unencrypted, was my previous request. Now this is my current request and everything is encrypted. And I have not redeployed anything. I have not changed my service, nothing. As a developer, I've not done anything. I've just applied these YAML files. Let me now disable so you can see that it's working. kubectl delete Istio files. Authentication enable TLS. Okay, now I've disabled MTLS. Notice that I can do the call, and here you can see that now the request is not encrypted. So you can really change from encrypted to unencrypted by just applying and deleting resources. Let's see another example about security with GWT. Okay, sometimes what we want to do is protect all services with authentication authorization using JWT, the GWT token. I know that it's redundant, but okay. Then, how to do that? It's really easy. You can again ask the developers to start dealing with the token. It's going to come a token with the authorization header, and then you need to verify that it has not been modified, that it has not been expired, that it contains the roles, the required roles to access, and so on. You can do it in that way, or you can leverage this to the service mesh. Let's see how. kubectl apply -f Istio files and user authentication GWT. Within this file, you can see it here, I'm just saying that to access customer preference recommendation, there should be a token, which the Istio is this one, and the GWKS is this one. Okay, if it's not coming a valid GWT token, then the request should be refused. Notice that I'm doing now a call. I'm just saying origin authentication failed because there is no JOT token in the request. Now I've got here token. This is the token. It's a valid token, contains no roles, no groups. It's just a valid token for the GWTS. Now, if I do a call -h authorization bearer, and I send, you can see here that I'm sending the token. Now it works. So I've applied some kind of authentication and authorization stuff without developing anything at service level. Everything is at network level. Now let's move forward and say, yeah, but I want to restrict. It's not just that I want that there is a valid token, but also I want to restrict by roles. And you can do that as well. kubectl apply -f Istio files authentication enable airbag. So I'm just enabling role-based access control, and then I'm just saying that I want to apply role-based access control in the case of using JOT. I can do a bat so you can see what I'm saying here. Okay, what I'm saying here is that to reach customer with method get, then I'm just setting I need a JOT token where the auth claims role. So there is a claim in the GWT token, which is customer. If not, it's not a customer in the GWT token. There is no role customer. Then the request is refused. Notice that if I'm doing this, now I'm saying airbag access denied, because this token, the default token, if I do this, sorry, here, this is the token. If I go here, and I'm going here, you can see that there is no group with role customer. But I've got here this other token, which, as you can expect, it contains this role. In fact, I can do again this token and copy this token here, going here, and you can see that there is a role which is customer. Now, if I do a call, I can reach the services. So notice that how easy it is to add security layer for your services without having to develop anything. Just as I said before, everything is at infrastructure layer because it was the infrastructure who put us these requirements. Now, of course, I can do kubectl delete -f Istio files, namespace policy JOT. Then I can just remove as well the authentication enable airbag. I can delete Istio files, the end user. And of course, now I can just start doing call again. Well, sometimes it takes some time now to get it again. Well, now it's taking some time, and now it's working. You know, to be without this GWT protection. So if you want to learn more about Istio, even if you want to try these examples, you can go to bit.ly/Istio tutorial. There you can see how to deploy all these services and how you kind of start playing with them and learning not just what I've showed you here, but more and more stuff like dark canaries, future graduation, dark canaries, shadowing traffic, so and so on. All these things are explained there in this tutorial. If there is also a cheat sheet, and also if you go to developers.redhat.com and you register, you will be able to download it for free, the Istio book. And that's all. If you have any question, I'm going to try to answer it now. But of course, you can reach me on Twitter. You can ask me whatever you want in Twitter. In YouTube, I usually post some videos. And of course, you can use the email. I mean, some people ask me, can I send you an email? And it's like, oh, of course, this is the reason why I put it here, the email. If not, I would remove it, right?